Here's the next question, number 36. In the figure, the capacitor initially has a charge of 10 coulomb. The current in the circuit 1 second after the switch S is closed will be. We have our four options: 14.7, 18.5, 40 and 50 amps. Okay. Now, what we will have to do is analyze the circuit, write down an equation according to mesh analysis or using mesh analysis, derive an expression for the current I, and then solve. So first let's write down what is given to us just to make things a little clear of what we have to use. We have been given charge of 10 coulomb. So that's Q is equal to 10. Then we have time given to us as 1 second. This is after the switch S is closed. And we will have to find out the current I. Okay. Now let's begin by writing down the expression, the circuit expression using mesh analysis. Okay. So using mesh analysis, let's write down the expression. Right. So we start with the source 100. Now 100 equals to R times I. Let's call the current that is passing through here as I. Okay. Plus, what is the voltage across the capacitor when charge is given? That would be Q by C. Alright, so we have 100 is equal to Ri plus Q by C. But what is I in terms of time? We know, let me write this down over here. We know that I is equal to dQ by dt. So let's substitute that over here. So this would now become 100 is equal to R times dQ by dt plus Q by C. Okay, let me just grab another sheet of paper and we will continue. Okay, now what do we have so far? We have 100 is equal to R into dQ by dt is equal plus Q by C. Now we need the charge to be positive. So what I'm going to do is bring R dQ by dt to the other side and writing the equation like this. Please check. That's Q by C is equal to 100 minus R dQ by dt. Now we'll take the common denominator and check what we have here. We have Q is equal to 100 C minus RC dQ by dt. Now I'm going to take 100 to the other side. Q minus 100C is equal to minus RC dQ by dt. Separating the variables and solving, we can now write this as dQ divided by Q minus 100C is equal to dt, that's minus dt by RC, right? So what I've done is taken Q minus 100C here and then RC down, just separating them. You will have dQ divided by Q minus 100C is equal to minus dt by RC. Alright. Now what we're going to do is integrating both sides. Now on the left side we are going to integrate it from Q0 to Q, because here our variable is Q. So here we integrate from Q0 to Q, and on the right side we integrate it from 0 to T. We'll integrate it from 0 to T, time T. That is from the time the switch has closed to the time given to us, that is 1 second. So anyway, since we are deriving an expression for I, let's keep it as 0 to T now. Okay, so integrating it, let's see what we have now. So when we integrate, integral of 1 divided by q minus 100c is ln of q minus 100c, isn't it? From q naught to q. And this equals minus t by rc from 0 to t. This is what we have. Oh, yeah. So that's ln, after integrating we now have ln of q minus 100c from q naught to q, which equals minus t by rc from 0 to t. Anyway, 0 to t will give us the same expression of minus t by rc, we can leave that. Now here let us substitute and write down what we have. We will get ln of q minus 100c minus ln of q naught minus 100c is equal to minus t by rc. Log a minus log b, ln of q minus 100c divided by q naught minus 100c is equal to minus t by rc. Now let's take the log on the other side, which now gives us a value of q minus 100c divided by q naught minus 100c is equal to e power minus t by rc, right? Now let's take this expression here. We would now have q minus 100c is equal to q naught minus 100c times e power minus t by rc. Isn't that right? Okay. Now we are going to differentiate this expression. Let's differentiate. Now differentiating that expression, let me write that down again. Q minus 100c is equal to q naught minus 100c into e power minus t by rc. Rc over here is the expression for tau. So that's q minus 100c equals this. Okay, so let's differentiate. Okay, so we are differentiating with respect to t. So when we do that here, q becomes dq by dt, constant, which cancels out, and that equals q naught minus 100c divided by rc, that's negative, right? So negative rc times e power minus t by rc. I hope this is clear as well. Now this would be 100c minus q naught divided by rc, taking care of the negative sign over here, times e power minus t by rc. So this is dq by dt. But we wrote in the beginning that dq by dt is what? It is the current I. So 100c minus q naught by rc times e power minus t by rc is the current I. Now let's write down, we'll substitute the values over here. Substituting, what do we get? 100 times, what was C given in the figure? It was given as 0.5. 0.5 minus the initial charge given in the question was 10 coulombs, so that's 10 divided by, what was R? R is 2 ohms, 2 times 0.5. Now solving this, okay, e to the power of minus 1 divided by 2 times 0.5. Now 2 times 0.5 is 1, which makes it e power minus 1. Now solving this entire portion, you will get the value of I. So here the final answer of I is 14.7 amps. You can solve it and check, you should get the value of 14.7 amps. And 14.7 amps matches with the option A. So for this question, the final answer is A, 14.7 amps. I hope it has helped.